So there's my system of equations. Pounds of metal, pounds of pure copper. That's what we described. Now, to finish here, let's see. How about we eliminate W by multiplying this equation by negative 0.22. So I'm going to work with decimals this time. And that becomes negative 0.22W minus 0.22S equals to, what is that? 0.22 times 120 is 26.4. But it's negative because I multiplied by negative. So if I add these two equations together, these two equations, we'll cancel the W's and we'll be left with 0.14S equals to 31.2 minus 26.4 is, looks like 4.8. And so if I divide by my decimal 0.14, then S will equal to, and it's going to be not a clean decimal, 4.8 divided by 0.14 is 34.2857, so on and so forth. Tell you what, let's run it off to one decimal place in this case. 34 point, I'll go with two decimals, 29. Okay, 34.29. Is one decimal enough? Is two decimals enough? Well, it really depends on the needs of this company mixing the alloy, isn't it? We don't know how accurate this has to be, how precise it has to be. The precision of this is going to determine how many decimal points we want to look for. And I've used 4 significant places. That's usually enough for most everything. All right, so S is 34.29, and W should be easy to get, right? Because W is the difference between the total of 120 pounds and the S number of pounds. So if I take 120 and subtract 34.29, then W is, and let me make sure you can see that. Looks like you can. W is 85.71. So let's write the answer. Okay, they need to mix 34.29 pounds, and I'll abbreviate pounds, LBS, that's from a Latin word for pounds, 34.29 pounds of the 22% No, I've got the wrong. S means what? S was the strong alloy. So this would be the 36% alloy. And 85 point, try to be a little more legible here, 85.71 pounds of the 22% alloy. All right, so there's our answer, communicated in clear English, complete with a capitalized first letter and period at the end of the sentence, as you're supposed to have. And does it make some sense? Well, to me it does, because if you look at 22% and 36%, what's the halfway mark there? And I believe it's 29% is the exact middle. So if we had to make a 29% alloy, wouldn't it make sense we would use equal amounts? But since we're supposed to produce a weaker alloy than 29%, then we should be using more pounds of the lower amount, the 22% weaker alloy. And so, to me, the fact we're using 85 and so many pounds of the weaker alloy makes a lot of sense. We should be using more of this in order to get a percentage which is closer to the 22% mark. To check this is a matter of saying, well, look, is 22% of 34.29 pounds, 0.22 times 34.29 is 7.5438, and 36% of this amount, 0.36 times 85.71, is 30.8556. If I add these together, it's going to be very close to well, it's supposed to be 36%, right? So did I do something wrong? Let me make sure I didn't punch something wrong. Well, 7.22 times 34.29, 7.5438 plus 30.8556. Wow, it's 38.3994. Okay, well, oh, that may be right, because this was the pounds from the 22% of the 36% alloy, and these were the pounds from the 22% alloy, and this is the total pounds. And how many pounds was I supposed to get? Was I supposed to get roughly 38.4 pounds? 0.26 times 120 is 31.2. Okay, so something doesn't look right. 0.22 times 85.71, and I see what I did. I made a mistake in checking. So I didn't plan for this, but you know, I think I'll keep it in the video. I got careless in my checking, and so let me be a little more careful about that. I got these numbers mixed up. So 34.29 pounds of 36% is 0.36 times 34.29. Alright, so I had my numbers mixed up when I was calculating, and I got careless. So it was 12.3444, and then 85 some pounds of 22%, so 0.22 times 85.71 is 18.8562. All right, now we add these together, and I got 6,004, 12, 31.2006. And if I multiply 0.26, the 26% times 120 pounds, I get 31.2. So this is slightly off from exactly 31.2 because there was a rounding error when we rounded these numbers off. So that's to be expected. So I left my error in the videotape because I want you to know that I screw up too once in a while, but I usually catch my mistakes because I try to make sure things add up correctly. So they weren't adding up correctly. Turned out I was punching the wrong numbers on my calculator. All right, so now I'm confident I have the right answer, and there we go.